Recall the definition of an acute or an obtuse triangle as well as the angle sum of a triangle. And let's have this activity. So find the missing angle or angles and identify whether the triangle is acute, obtuse, or neither. Number one, we have this triangle. Then we have this second triangle and this third triangle. So how did you find the measure of the missing angle in each triangle? So again, for the answers, we have the missing angle here is 90 degrees, and this is neither acute nor obtuse. For this second triangle, the missing angle is 120 degrees, and this is an obtuse triangle. Here, the missing angle is 70 degrees, and this triangle is an acute triangle. Now, I'd like you to answer activity 1.1. Can you guess on page 5 of your learning package 1 and transfer your answer to the LMS once done? Now, recall also the bridging topics that we have discussed when we met a little less than 2 months ago. So, let's recall the six trigonometric ratios. Again, remember the mnemonic SOHCAHTOA. So sine theta is equal to the opposite side over the hypotenuse. Cosine theta is equal to adjacent side over the hypotenuse. Tangent theta is equal to the opposite side over the adjacent side. Cosecant theta is equal to hypotenuse over the opposite side. So cosecant theta is just equal to 1 over sine theta. Then we have secant theta is equal to hypotenuse over the adjacent side. Or secant theta is also equal to 1 over cosine theta. And then we have cotangent theta, which is equal to the adjacent side over the opposite side. Or cotangent theta is equal to 1 over tangent theta. Now let's have an example on this. Solve right triangle ABC with right angle at C given the following parts. Angle A is equal to 48 degrees and 12 minutes, and side B is equal to 18.5 meters. So to illustrate, this will be our triangle, right triangle ABC. Now, how do we solve for angle B? So to solve for angle B, we will have angle B is equal to 90 degrees minus 48 degrees and 12 minutes. Take note that angle C here is equal to 90 degrees. Okay, and the angle sum of a triangle is 180 degrees. So since angle C is 90 degrees, therefore to get angle B, just subtract 48 degrees 12 minutes from 90 degrees. Now, how do we solve for side A? So again, since we are given a right triangle, therefore we can utilize SOHCAHTOA here. So to solve for side A, we can use tangent. Okay. So angle B here is equal to 41 degrees, 48 minutes. Now how do we solve again for side A? So to solve for side A, we will be using tangent. Now remember here, we are given a right triangle, so therefore we can use SOHCAHTOA. So here, applying tangent, we will have tangent 48 degrees 12 minutes will be equal to A over 18.5. Remember, TOA. Tangent is equal to the opposite over the adjacent. Here is the 48 degrees 12 minutes angle. So the opposite side of that is A. This is side A over the adjacent side, which is 18.5 meters. This side AC. Next, to solve for A, we will cross multiply. So A will be equal to 18.5 times tangent of 48 degrees 12 minutes. And that will be equal to 20.69, rounded to two decimal places. Now we have solved for angle B, side A. Therefore, this time, let us solve for side C. Now, how do we solve for side C here? What can we use? Now, to solve for side C, we will use cosine. So, cosine of 48 degrees 12 minutes will be equal to 18.5 over C. Remember, ka. Cosine is equal to the adjacent side over the hypotenuse. Here, this is our angle, angle A, 48 degrees 12 minutes. The adjacent side here of angle A is 18.5. This one, side AC. Over the hypotenuse, remember, is the longest side. That is the side that is opposite the biggest angle. So this is the 90-degree angle, angle C. Opposite of that, that will be the hypotenuse. And this is your side C. So again, cross multiplying here, we will have C times cosine 48 degrees 12 minutes will be equal to 18.5. And therefore, dividing both sides by cosine 48 degrees 12 minutes, we will have C equals 18.5 over cosine 48 degrees 12 minutes. That will give us a value of 27.76. So side C is 27.76 rounded to two decimal places. Now you may now proceed in answering activity 1.2, remember me, on page 6 of your learning package 1, and transfer your answer to the LMS once done. Now, before we proceed, I'd like you to go to page 7 of your learning package 1 and answer activity 1.3. Are you me? And I'd like you to answer these questions. Observe the given angles and the values you have obtained. What do you notice? And number 2, based on your observation, what conclusion can you make? Now, I'd like you to take note of the values that you will be getting after answering activity 1.3. Now, for our discussion, this will be our learning competencies. 1. Illustrate the law of sines. 2. Solve a given set of oblique triangle problems using the law of sines. An oblique or general triangle is a triangle that contains no right angles. So again, if a triangle is not a right triangle, then it is an oblique or a general triangle. Now, what's the significance of knowing whether you are given an oblique or a general triangle? Now, we shall know this as we go along with our discussion. Now, we will be using the standard notation of labeling vertices of a triangle using capital letters A, B, and C. And we will be using small letters A, B, and C as labels for the sides of the triangle. And opposite angles, capital A, B, and C, respectively. So angle A is the angle opposite side A, angle B is the angle opposite side B, and angle C is the angle opposite side C. So you are still familiar with an acute, a right, or an obtuse triangle. Okay. You also know now how to compute for the missing angles of a triangle using the angle sum of a triangle. Now I'd like you to go to activity 1.4, Where Do I Belong, on page 7 of your learning package 1, and answer the given activity. You may transfer your answer to the LMS, your answers to the LMS once you're done reviewing them. Now, solving a triangle means finding all those sides and angles that are not given or known. Now, to solve a triangle, we need three parts, and that three parts must include at least one side. So if one side is given and two angles are given, then we can solve the triangle. If two sides and an angle are given, then we can solve it. If three sides are given, then we can still solve the given triangle. So take note that we need at least one side to be given for a triangle to be solved. So when you say solve, when instruction says solve a triangle, that means you will be finding the lengths of those three sides of the triangle as well as the measures of the three angles of the triangle. Now, in grade 9, you have discussed the Pythagorean theorem. So, for right triangles, when we are given right triangles, we can use the Pythagorean theorem or the SOHCAHTOA to solve for the unknown sides or angles of the triangle. But for oblique triangles, meaning triangles which are not right triangles, then we now use the sine law or the cosine law to solve for such oblique triangles. And this is now the start of our grade 10 math topics. Now I'd like you to answer activity Now I'd like you to answer activity 1.5, deriving the law of sines, on pages 8 to 9 of your learning package 1. Okay, and once you are done reviewing your answers, you may upload your answers to the LMS. Now, solving any oblique triangle falls into one of four cases where the following parts of a triangle are known. So, 1, two angles and a side opposite one of them. Now, this is the AAS or ASA case. Second, when two sides and an angle opposite one of them are given. This one is called the SSA case. SS meaning the two sides. This A here pertains to the angle opposite one of those sides. Third, when two sides and the included angle are given. This case is known as the SAS or SAS case. So as you can see, A here is in between the two angles, meaning angle A here is an included angle, or the angle formed by these two sides. And fourth, when three sides are known, and this is called the SSS case. Now let's try to find out whether which among these cases can the law of sines be applied. And then later on, which among these cases as well can we apply the law of cosines. Now what does the law of sines state? Now the law of sines states that the side of an angle of a triangle divided by its opposite side is equal to the sine of another angle divided by its opposite side. Now to further illustrate this, for a triangle with sides A, B, and C and opposite angles A, B, and C, the following is true. So this is our triangle. This is triangle ABC. As you can see, angle A is here. The side opposite angle A is side A, denoted by the small letter A. This is angle B. The side opposite angle B is side B, denoted by the small letter B. This is angle C. The side opposite angle C is side C, denoted by the small letter C. Now, sine A over A will be equal to sine B over B, and that is also equal to sine C over C. Or, this is also true, A over sine A is equal to B over sine B, and is also equal to C over sine C. So, these are the proportions that will hold true given this triangle under the law of sines. In other words, the ratio of the sine of an angle in a triangle to its opposite side is equal to the ratio of the sines of the other two angles to their opposite sides. Okay, so just take note of this formula. Sine A over its opposite side A will be equal to sine B over side B, and also equal to sine C over side C or C. Now, just take note of rounding angle measures to the nearest minute. So, these are examples. For example, in here, number 1, the given angle measure is 12 degrees, 42 minutes, 25 seconds. We read this as 12 degrees, 42 minutes, and 25 seconds. Rounded to the nearest minute, this will be 12 degrees and 42 minutes. Why? So this is the reason. Since the seconds part is below 30 seconds, Remember here, the seconds part is 25 seconds. 25 seconds is below 30 seconds. So therefore, we will round down. In other words, we will drop the seconds part. That's why this will now be 12 degrees and 42 minutes. Now in number 2, the given angle measure is 12 degrees, 42 minutes, and 30 seconds. Rounded to the nearest minute, this will now be 12 degrees and 43 minutes. Why? Since here the seconds part is 30 seconds, so therefore we can add 1 now to the minute part. So if it's 30 seconds or more, then we will round up or add 1 to the minute part. Here in the third angle measure given, we have 12 degrees, 42 minutes, and 35 seconds. Rounded to the nearest minute, this is also 12 degrees and 43 minutes. Why? Since the seconds part here is 35 seconds, which is greater than 30 seconds. So therefore, we will round up or add 1 to the minute part. Now remember, to round an angle to the nearest minute, if the seconds part of the angle measure is below 30 seconds, we drop the seconds part. Now, if the seconds part of the angle measure is greater than or equal to 30 seconds, then we add 1 to the minute part. So the law of sines is useful in solving oblique triangles when we know the following information. So these are now the cases wherein we can apply the law of sines. So case 1, when two angles and one side are given, this is also called the SAA case or the ASA case. So two angles and one side are given. And case 2, when two sides and an angle opposite one of these sides are given. This is also called the SSA case or the ambiguous case. So again, case 1, SAA or ASA case, meaning you're given two angles and one side. And case 2 is the SSA case or the ambiguous case, meaning here you're given two sides and an angle opposite one of these sides. Now let's go to case 1. Two angles and one side are given, or the SAA or ASA case. Let's have this example. Solve triangle ABC if angle A is 42 degrees, angle C is 70 degrees, and side A is equal to 6. So this is our triangle. So take note of the labeled parts, the given. So note, when we say solve a given triangle, we mean that we need to solve for all of its three angles and all of its three sides. So we need to solve here for the values of sides B and C as well as angle B. Now, how do we solve for side C? So let's try solving for side C first. So to solve for side C, we can use this proportion. Sine A over A equals sine C over C. Now, why this proportion? Why not sine A over A equals sine B over B? Why not that proportion? Why this? Now, we can use this proportion because looking at the given, you are given angle A, so angle A, check. You're given angle C, so C, angle C, check. And you're also given side A, so A is check. Okay. Now, since only side C is unknown, or not given. Therefore, we can use this proportion or formula to solve for side C. Now, take note that in a formula, there should only be one unknown so that we can solve that formula. Okay, so here, only side C is missing. All the rest are given or known. Therefore, we can use this formula or proportion. So by substitution, we have, so angle A is 42, so we have sine of 42 degrees over side A is 6 equals sine C, C is 70 degrees over C. Next, we cross multiply, we have C times sine 42 degrees is equal to 6 times sine 70 degrees. Now, to solve for C, side C, we divide both sides by sine 42 degrees. So here we will have C equals 6 times sine 70 degrees over sine 42 degrees. And using our calculator, we will arrive at this value. So C is equal to 8.43, correct to 2 decimal places. So again, in this example, this case falls under the ASA case because here you are given two angles and one side. So angles A and C are given as well as side A. Now we have solved for side C. Let's try solving for angle B. So to solve for angle B, notice that angle B here is unknown. Now, in your grade 8 mathematics, you have learned that the sum of the measures of the angles of a triangle is 180 degrees, or the angle sum of a triangle is 180 degrees. So therefore, if you add all the three angles, A, B, and C, that will add up to 180 degrees. Substitute the values, we will have 42 degrees plus B plus 70 degrees equals 180 degrees. So angle B plus 112 degrees, if you add these two angles, that will be equal to 180 degrees. So angle B will be equal to 180 degrees minus 112 degrees, and that will be equal to 68 degrees. So angle B is equal to 68 degrees. So we have solved for side C for angle B. Next, let's try solving for side B. So to solve for side B, again, we will use the sine law, so we can use this proportion. Again, why this proportion? Because here, the only unknown variable is B, side B. Angle A is given, side A is given, angle B, we have solved it. So the only unknown here is B, side B. So substituting the values, we get this. Sine 42 degrees over 6 equals sine 68 degrees over B. And then by cross multiplication, we will have B times sine 42 degrees equals C times sine 68 degrees. To solve for B, we divide both sides by sine 42 degrees. So we will have B equals 6 sine 68 degrees all over sine 42 degrees. And that will give us a value of 8.31. So the length of side B is 8.31. This is rounded off to 2 decimal places. At this point, you may now answer activity 1.6 Law of Sines, ASA or AAS or SAA case on page 13 of your learning package 1. So answer in your printed modules first and then transfer your answers to the LMS once you're done reviewing them.